Hello, my name is Aaron Snow, and what you see behind me is a complete and total mess. So don't worry about that. It's not how I live. It just happens to be this way today, and sort of digging through things and looking at stuff, and so I've got stuff scattered everywhere. And what this video is about natural language processing. Now, well, most people would call it an NLP. Now, I kind of like to go over some ideas and some theories, and I really don't entirely know the direction that this video is going to take, and I'm just going to do this thing logically and on the fly, and just see where it takes us here. Now, a natural language processing thing, whatever, is NLP. You have it starts with the word natural. Now, or a natural language. Now, there are plenty natural languages, like English is a natural language, Spanish is a natural language. These languages have changed over time. I've recently watched the history of the English language, and it goes back for about 1,500 years, and it was constantly changing. Even the grammar has been changing. Everything has been changing, and they try to like nail it down at times and saying, well, let's call this English. And it nearly got totally wiped out a long time ago. There was like one kingdom left that spoke English. And what happened was the French, well, I say the French. At that time, it's just I think, basically the Vikings and stuff like that. It's one of those groups over there. I can't tell you exactly. But anyway, they spoke some pretty interesting languages. I think French was one of them, and French goes back forever. The French language goes back way further than France does. So, but the English language was almost totally wiped out in the early days. And there was like this one king that held out from being invaded by those enemies that came into the land, and they spoke English, and if they got wiped out, pretty well the English language would have gotten wiped out because everybody would have been forced to speak this other language. But of course, English back then didn't sound like English today. It's just totally different, except for some minor grammar things and certain types of words, like the word father and son, have those languages go back to Sanskrit. I mean, those pronunciations go back to Sanskrit. And so we've had some a very unique language, and the English language in general is a hodgepodge of a variety of languages. I mean, like I used the word hodgepodge, telling where that came from, actually. Most of English language consists of French, Irish, just a variety of everything. We absorb languages. Even Native American is in our current language. It's just we absorb languages. We absorb other words from other cultures. That's what the English language did. And so you think, well, if it's a hodgepodge, how do we make sense of this? I mean, how can we process a natural language since it's so sporadic now, or so crazy, But before we can answer that, I want to compare this to something else, just because we can at this point. I get rid of this right here. There's something called a CLP. That's constructed, constructed language. And a constructed language is Klingon is a good example of a constructed language. A constructed language is a man-made language that was made usually by one person or a couple of people, and it's extremely logical. It has a lot of stuff we wish we had in the English language, and of course other natural other natural languages, like even Hindu or whatever. These languages, they they need some logical order to them, but a constructed language is exactly what we wished natural languages had. You know, they have low variations, low, idiocracies, or whatever you would say, dumb little changes like, you know, irregular spelling and things like that are virtually wiped out in constructed languages because they were made by one fellow and they didn't change over time. They just are what they are. Esperanto is a language they were wanting to speak in the UN because it was a constructed language. It was easy to learn, and they wanted to use Esperanto as a UN language. And that's another thing good about constructed languages is that not only are they consistent in their grammar and speech, they are also much easier to learn usually because they're simpler versus a natural language, which is usually pretty crazy. It's got all these weird ways of saying things. And that sort of leads me into this next topic. I mean, we're looking at an NLP, natural language processing. Well, what is that? That's to process a language, in this case, a natural language, to process it. So it involves computers and taking and data mining text, not just a sentence, but text in general. Now, where we have more free play and larger text, but when we get down to small snippets of text, like a sentence, for instance, it's much more logical in its construction. And the reason why it's logical, it's like the smallest true bit of information. You're trying to explain something. The smallest understandable pieces of information reside in the sentence, at least amongst a simple sentence. And in this sentence, it's basically a structure. And what we do when we hear a sentence, we know exactly, of how the word is placed in that sentence. We know what the word really means and what kind of intention that we understand the speaker is trying to get across. Like the word to express a question means to query data, and we'll say something like are you okay instead of you are okay. You are okay is almost telling somebody you are okay. It's not a question, but when we say are you okay, now we've changed the structure of the sentence and somehow it becomes a question. And we've all agreed on this. It's like naturally agreed that this change in structure of that sentence produces a completely different meaning. We use the same words, are you and okay, but because we changed it around, it took on a completely different meaning. So natural language processing involves data mining sentences. Like, well, does it have is it set up with are you okay? Well, that must mean it's a question. Okay, for instance. And another thing, like, number two, a natural language processing involves lots and lots of classification. It's like low level and high level programming. It's you've got different levels here. Like the lowest level, if you're going to process a sentence, you can process it directly, for instance, and that's like really low level stuff. Like, we know the word are you okay, or whatever you spell it like that, I suppose. Are you okay? That's the basic low level sentence. I ran fast. That's a very basic low level sentence that we can sit there and look at the word I individually. We can look at the word run individually, and we can look at fast individually. I'm going to try to contrast this so you understand what I mean by low level real quick. Now, a high level is classification. So, like the word I, an I is a pronoun. Let's see. I'll spell it correctly. That's stupid. Like, anyway, I hate to misspell something so easy. Pay attention, Aaron. Okay, pronoun. I is a pronoun. It is a what do you call a there's proper nouns. It's like a proper pronoun. That's why you capitalize the letter I when you say I, even wherever it is in the sentence, because we know it's expressing a specific person, and it's almost like in place of a name, and so you capitalize the letter I, and it's like the only one you really do capitalize, I think. Anyway, so we got I, which is a pronoun. You got run or ran, whatever. That's your verb. It's an action verb. There's transitive and intransitive verbs. And then you have the word fast. Now, fast is an adverb. So we got pronoun, verb, adverb. Now, this right here is like a classification that a sentence can fall in the line of pronoun, verb, and adverb. Okay, this is like high level. See, when you say I run fast or I ran fast, you are expressing a single thought, and you can't really say it much different than that. Fast I ran, Yoda said. Anyway, so on a higher level, you've got pronoun, verb, adverb. I run fast, but you could also say he sits quickly. Just whatever. He sits quickly. She walks slowly. There you go. She walks slowly is another example. And so I can write a lot of sentences based upon this structure: pronoun, verb, adverb. Right? So, there's also little things like agreements between the pronoun and the verb and stuff like that, and the different ways of, you can say he quickly sets. That would be a pronoun, adverb, verb sentence. But anyway, you can see this is it is acceptable to write a sentence with pronoun, verb, and adverb. That is a classification. So now we know that if something we know, for instance, if the word being spoken happens to be a pronoun, happens to be the next word is verb, and the last one's adverb, we know that it should be an acceptable sentence. That the computer sitting there processing this information, saying, well, okay, this is a good structure of a sentence. In fact, if the computer decided to generate a sentence, it could randomly pick a pronoun, she, they randomly pick a verb out of this list. Imagine this being a really long list of words. Okay, what kind of pronoun? Well, we have he, she. Okay, we'll choose the word she. Okay, what kind of verb we have? Well, I have sits and walks. Well, we'll choose the word sits. Adverb, slowly. We just randomly pick one. The computer can sit there and randomly pick a sentence out. So we can say she sits slowly, and that makes sense because it fell under that sentence structure based upon a classification. Now, see, that's it's like the lowest level are words in general. The next level up is like the classification of words, but then there's something even higher form of processing. I'm sure this stuff has a name, but it's actually stuck in my head. You know, what can I say? I have to deal with. I don't know the names of what I'm doing. It probably has some type of scientific name. The study of such and such language processing, this and that, and I don't know what I'm doing. I'm just stuff that's stuck in my head. That's what this is all about. The next level of of natural language processing, you know, you got low level, mid level, got a little bit higher level, and it's something like you know, before we had pronoun, yeah, PN for pronoun, verb, and adverb. Okay. Now a higher level would be subject, Um, yeah, I say, well, you have subject, predicate. Well, we got subject, action, and oh, modification. I don't know. You could have something more general. Modification, I guess. It's more of a general classification. What I'm trying to get at. See, this is like mid-level classification because it only classifies the words that we say it's in a certain order. But then we get to higher, more abstract ideas like subject, action. Well, I like to say, I give you an idea, a better example of this. I use the words agent, action. Let's see, what else is there? You got your agent, you got your action, you got your patient. And that's like saying you got your subject of the sentence, you got your verb, and then you have your object of your preposition, something that's being acted upon. So you got the one doing the action, you got the actual action that's being done, and then you got the one being affected by the action. And it's a very general, abstract view of sentence parsing. Like a sentence can fall in that category. The patient could have a, you know, be an object of a preposition. It could actually qualify as many words. You could say the agent could be the ball. Agent could be quickly ran, and patient could be excuse me, quickly fell. I don't know why a ball would be running. Yeah, quickly fell, and I put 3 L's in there. Oh, I have too much fun with this. Okay, the agent is the ball. Actions quickly fell because it fell, but it's like a specific type of falling. It was a quick fall or quickly fell. And then we have patient. Quickly fell. Let's see. To bill. Whatever. Just pay, you know, okay, or probably a better one. Quickly hit. There you go. It's what you do on the fly. You have to make up stuff. The ball quickly hit Bill. Fat Bill. We'll just add another word to give an example of what this can do. Fat Bill describes Bill, but it's the object of the sentence. It's the one being hit, or Bill's the one being hit. Quickly hit is what's happening. It's not just hit, but quickly hit, but that's the action. So it's like a whole section here. And it divides up into larger chunks. And so not only do we have an article, the first one's an article, then it's a noun, then we got adverb, ADV, We got hit, which is a verb. Fat, which is an adjective. AGDV. And then Bill's a noun again, which is not just any noun, but it's an object of the direct object is what that is. And of course, my picture's covering it up, but you basically understood what I'm saying here. So it's a higher level. It's more of an abstract view. You had your low level with words. It was like very specific about its case. Then you had your mid-range stuff, which is your actual classification of words, which could be crazy, specific. You don't have to have a verb. You can have an intransitive verb. An intransitive verb doesn't have a direct object, but a transitive verb does, or something like that. Anyway, you have direct objects, you have indirect objects. You have, all these special things that's written in sentences. So it is a structure, this structure of a sentence written out to convey information over to an individual. Now, sentences, even though it is a natural language, sentences are made to be logical. If they're not logical, then we do not understand what they mean, and they're pointless. Like, they carry information, so they have to be logical. It is an operating, you think of a computer, you have low-level operations that occur within a computer, and then you have something called the operating system, in which the computer actually functions that we interact with, like Windows is an operating system that Microsoft created. Now, there are machine code down at the lower levels, but we interact with the operating system, and there's a language of the operating system. It's a higher level language. It's easier to understand. It's of a higher level, and that's what sentences are. They're a higher level piece of chunk of information. We don't know exactly what kind of bits and how bits are stored within our brain. We're not paying attention to what data goes where within our own minds, but we deal with an operating system that functions on a logical brain programming language, which is an NLP, a natural language processing. Whatever you could say, it's a programming language. It's just our programming language. English or Spanish or whatever language that you speak. I suppose you know English because I speak in English, and obviously you're probably watching this right now thinking, yes, I understand at least most of what he's saying. So, if you have to keep this stuff in mind, it is important to keep this information in mind when creating an NLP or an actual processing or processor for a natural language. Like I showed you a while ago, I gave an example about you could randomly choose and create a sentence based upon, simple pronoun, verb, and say pronoun, verb, and adverb relationship, in that little structure. You can also do that on the higher level stuff too, about subjects and actions and patience, and there's more things you can attach to a sentence as well. There are other little things about the English language in particular that we like to add information to, that we don't have to have different words to express plurality, for instance. We don't say, car. You can say there are many car. It wouldn't make any sense. Wouldn't be grammatically correct, because we didn't add the S on cars. But you can say there are many car, and that there are multiple cars out there. When we say multiple things, we usually add the S on the end of it. But really, all that is additional information. If we were creating a language, we could say, just say many, yeah, whatever here. We could say many car, and that actually sounds like an Indian language. Many car, many tree, or something like that. It's like you can't quite get the English language down very well, so you like forget that you need to add an S to something like that. But so there's a basic bit of information being expressed in this situation. We had this S, but really all we are doing is adding more information to the sentence. Um, all like I said before, all these sentences are just conveying information. So technically, if you were creating a language, it seems like I've stepped into, you know, here I am progressing in this talk, and we've talked about, language structure, a hierarchical structure, and now about natural language processing, and now we're like talking about creating a language. But it's like if we were to create a language, we could actually express everything we wanted to in one word. We could say uh, car, and to express, many cars, we put an S. We kind of do that in English, and say that they're all red. We could put a red for red, and so we could say cars are red. That means there are many cars and they're all red. We can encode information in just simple words. And basically, words are symbols that express real life objects usually. And you can think of it like that, but words also, the way they're built to do mathematics with those words. It's like this one fellow was saying, I heard on the forum or whatever that I was, interacting with a certain forum on the computer, and they were talking about, how words often need to have context with reality to really truly understand things. Now, that is absolutely correct. A blind man who's never seen anything can't really fully comprehend, what objects look like because they've never seen an object and they don't know what looking really means. Without context, words don't have a whole lot of meaning. And what we do here is we attach the real world, the context of our reality, and we associate those things with words, and then we add properties to words. And so, to take the word car, we know that there are many things that are associated with the word car. We know that it's a thing, so there are, a classification that a car is a thing. It's not just a noun, but it's a specific type of noun. It's called a thing. And things have weight, IGHT. Things have weight. They have color. They have length, width, and height. I won't write that down. They're 3D. They have all these aspects. They have speed. They can go fast. They can go slow. They are measured in miles per hour. And there's all this information that can be added to this list of what a car can be. And we can add to that list actually within using a sentence. So we add information about this car. We can actually say that there's more information available. Maybe one day that we develop another sense and we realize that cars have a few more other specific traits we never did, know about before, whatever. It seems like, some people know things about cars. Some people know more things about cars. Like, for instance, a car, what's its miles per gallon? You could say what's the car's um, How much power steering fluid, does it take, to fill up the power steering fluid reservoir? It's just all that you can get in really specific information pertaining to cars. And so you got more general information and more specific information. And this is very pertinent. This context is very pertinent when it comes to sentences. You have to have context sometimes to understand a sentence. If you don't have context, sometimes sentences don't mean anything at all. And so there is a bit of understanding that happens. We call it natural language processing. There's a natural language understanding, and understanding has to do with a context generally. To be able to break a sentence down into its parts and pieces is important, but to to really understand the meaning behind it, you have to have context, and that requires a totally different type of database. That requires an association type of database, like what I just got through drawing a while ago. So you have to be able to, first of all, break a sentence down and then be able to store information out of that sentence and then actually do some logic, perform some logic with this information to create an understandable action or an understandable response, say from a chatbot, for instance, like Athena. You got to be able to get information from these sentences, and then you're able to use this information, store this information, and then respond with this information. And we information building upon more information. So we create this context library that where everything is associated with each other based upon hierarchical and association. That's just not just flat out association. Red, the color red can have association with a man, but you would say perhaps a red skin or a red sore on their face, or their blood is red. You want to be more specific. So we got this scale of information. And I really don't want to go into too great a detail because I know this is all a hodgepodge of information, and it wasn't really intended to be super logical anyway. But anyway, that's just some of my crazy ideas. You have to consider and take all this into account when you're building a natural language processor. And if you don't really have a natural language processor. But it's very doable. It just takes a lot of time and effort. It takes a lot of logic. You have to be able to break down these things into your sections. You've got your, on one side you've got your your basic language processing, which is your low level stuff with your words. You got your mid level stuff with your word classifications, and then you got your higher level things like the more abstract view of a sentence. And then on the other side, you've got to deal with context and what properties does each noun have? What properties do each verb have? The actions have properties to them as well. Actions, a list of properties usually is like a list of adverbs. It's like adjectives describe nouns, so an adjective is like a property of a noun. The red dog. And a property of a noun is like color. What kind of color? Red is a color, so yes, it's a red dog. Can a dog be red? Well, if you're a cartoon character, yes, a dog can be red. So that gets into context. It went from a sentence structure to context. Let's see. That's and with verbs, like I was saying a while ago, you have like quickly ran. He ran quickly. That's like an option, or it's like a property of the word that helps describe or modify the verb ran. So quickly ran, an option to ran. It's like I slowly ran, quickly ran, lopsidedly ran, indignantly. I can't pronounce it. It angrily ran. You know, it's like it expresses an emotion. If you're angry, you end up running a certain way. So it's like an option to run. Uh, anyway, with running, there's also the property of speed. Exactly how fast did you run? The manner of which you run, which is again, just like slowly ran, it's like a manner. Um, and there's a whole list of actual classifications that fall under that. And most of this stuff I've written down. I've written down the classifications of verbs, classifications of nouns, you know, the more general abstract type of things. And it's extensive and it is annoying and it's a brain teaser. But anyway, that's what I have so far. I'm probably a lot more things I could talk about, but I'm already feel like I'm rambling. But again, this is the point of the video, to do some rambling. Anyway, hope everybody is okay with this, and let me know how you feel and make a comment or say something wherever this video is posted and whatever you think. Let the games begin. Anyway, I appreciate you guys for listening and have fun.